Okay, good evening. Assalamualaikum warahmatullahi wabarakatuh. I would like to present our article entitled "The Application of Data Acquisition System and Airflow Control System in an Air Dehumidified Drying Machine." I am Muhammad Bagus Hermanto. Well, the objective of this drying are to reduce grain respiration by removal of excess of moisture. So we need to reduce the moisture content and then to prevent the qualitative deterioration of seeds in storage. So because the excess of moisture can support the growth of microorganisms and activities of insects. So this suitable design for seed drying system is an important step to produce high quality of agricultural seed. The agricultural seed production, for example, corn seed, use the 38 until 43 degrees Celsius for drying its seeds. And for example, pepper is suggested at 35 degrees Celsius. Well, the previous research, uh, Susilo et al. To 2020 did a research about the performance of drying machine with air dehumidifying process for sweet corn seed. This method is reducing the air moisture content so that the drying temperature for seed can be lowered with the low relative humidity, of course, so the drying rate will be accelerated. And some problems that need to be solved from the previous research, for example, the first one is the drying capacity of the machine was less than 1 kilogram. We want to increase the drying capacity by modifying the existing machine, drying machine. And then the heat from the condenser is not yet utilized. The third one is the data acquisition system was needed to collect real-time temperature and humidity profiles during the drying process. And also the airflow control system for ensuring that the humidifying temperature was under the dew point temperature. So this research objectives is to apply the data acquisition system and the airflow control for seed drying. This research was conducted at our laboratory in University of Brawijaya, Laboratory of Mechatronics and Food Process and Agricultural Project Engineering. These materials and used for this research is the microcontroller, of course, the Arduino Mega, and the sensors, GHT22 sensors. This is sensor for temperature and also humidity. Micro SD module. This is for saving the temperature and humidity data into micro SD card. And LCD, this one is for monitoring the temperature and humidity, and of course the software for programming the microcontroller. This one is the previous design, and this one is the modification design. We have a control box. This one is the evaporators. This one is the condenser, number 3. Number 4 is heat recovery unit, and number 5 is drying chamber. Well, the dehumidifier process is conducted at number 2. This one is the air dehumidifying process here. This one use the refrigeration cycle of the air conditioner. So we use air conditioner here to make the air temperature uh, uh, have some condensation, so the air vapor will be condensed at this dehumidifier unit. And the working principle is as I mentioned before. So the low humidity air will make the difference in material vapor pressure. So it will increase the drying rate. So the drying at low temperatures and also low humidity, as expected for the seed drying requirement, was fulfilled. This one is the dehumidifier drying machine. We have 5 units here, and this one is the data acquisition processing with six sensors. All sensors are placed in first sensor in ambient to measure the ambient temperature and humidity. Second sensor to the dehumidifying unit here. Before the recovery unit, after the recovery unit, drying chamber, and the outlet. All sensors are calibrated, and these equations are used in the Arduino Mega, the microcontroller. So the data from the sensor, calibrated sensor, can be seen at the monitoring system in LCD uh, with 2 rows LCDs, and also can be saved in micro SD card by using micro SD module, and also for controlling the airflow system here using a relay. This use airflow control system. This one is airflow control system. Well, the control system cut off the airflow if there is no condensation in the humidifier system. So the working principle is like this. If the temperature in the humidifier chamber is less than dew point temperature, so the fan will on. Yeah. So during the experiment, the fan is on after 20 minutes after the system started. So in 20 minutes, yeah, the temperature in the humidifier chamber is not yet reached the dew point temperature. So the fan is of no flow to the uh, drying chamber. This one is the temperature profile. The ambient temperature is about 29. The dehumidifier temperature is about 13.5. And after the heat recovery, yeah, from 13.5, we increase it into 19.5 by using the dissipated heat from the condenser. Yeah. This one from 13.5 to 19.5, we use dissipated heat from the condenser. And from 19.5 to the set point 41, about 41 degrees Celsius, we use a heater, electric heater. So it will reduce the energy requirement from the from the electricity. So the reduction is about 38.2%. This one is the relative humidity profile. So we reduce the ambient temperature from 74% into 32% in the drying chamber. So lower relative humidity here will cause a faster drying rate. So this heat recovery unit is very important for decreasing the energy requirement. to increase the temperature into expected drying set point? Well, from A is the ambient temperature here, B is dehumidifier, C is heat recovery unit, D is drying chamber. So from B to C, we use heat dissipated from condenser. C to D, we use electric heater. And this one is the comparison between the other drying methods. So this one is almost the same with the previous research, and it is compared to the ambient drying and the sun drying is uh, better. We have better results. And this one is also we have good results here because the previous result has a lower capacity. We have larger capacity of about 5 kilogram per batch. This one is less than 1 kilogram per batch. So in average, we have also good results here. And from this modified dehumidifier drying machine, we reduce 40% relative humidity from the ambient. In conclusion, the data acquisition system applied for dehumidified drying system based on Arduino Mega microcontroller with 6 sensors. The airflow control holds the airflow to the drying chamber until the water condensation occurs at the dehumidifier unit. And the heat recovery unit can restore the air temperature after air dehumidification. So it's about 38% close to the ambient temperature. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.